to this tutorial platform. I am instructor Victor. Now we are into another question from a formation of a differential equation, and we are asked to form a differential equation from the function y equal to a exponential x plus bx. Now, as I've earlier told you, as I've earlier discussed in my previous class, I say that whenever you are given a function to form a differential equation, first look at the arbitrary what? Constant. Now, at this point, we have two arbitrary constants, which is a and b. And what are you going to do with that? When you have two arbitrary constants, you are going to be what? Differentiating twice. Then let us solve so that you understand better on what I am saying. Now, solution to this question, you have that y is equal to a exponential x plus bx. Now, for you to execute this, don't forget we said that to form a differential equation, we are going to be differentiating that ordinary equation as many times as there are number of what? Arbitrary constants, which means that we have two arbitrary constants. We are going to be differentiating that ordinary equation into two times, because those are the what? The number of times that we have a arbitrary constant. Then after that, we will look for a way to eliminate the what? The arbitrary constant, and then form our differential equation. As simple as that. Now we have two arbitrary constants here. We are going to be differentiating twice, which is y prime equal to, when differentiate a exponential x. Now exponential x has this way of what? Differentiating. When you differentiate exponential x, and this is what you are going to do. You are going to be differentiating what you have up here, and then use it to multiply the exponential itself. If you differentiate x, you are having a 1. Now 1 multiply the exponential x, you have exponential x, and this will tell you that what? Exponential x is the only function that its differentiation is equal to what? The function itself, because when you differentiate exponential x, you are going to be having the same exponential x. Now don't forget your constant, which is exponential x, plus when you differentiate x here, you're going to be having 1, which is a b. You will left with what? B. Now this is your first differentiation. You have differentiated for the first one. Now the second differentiation will give us y prime prime, which is a exponential x. When you differentiate a exponential x, you still have the same a exponential x. Now when you differentiate b, you're going to be having a 0. You're going to be having what? 0, because when you differentiate a constant in differentiation, your answer turns to what? 0. So I may leave my answer to be plus 0, or you may clean your own, showing that it has turned to what? 0. Now we are done differentiating as many times as there are number of arbitrary constants in our ordinary equation. Now we will now look for a way to what? To eliminate those arbitrary constants. Now, how do you eliminate these arbitrary constants? We may use determinant of a matrix, or we may apply what? Simultaneous equation. All we care about is what we can do to eliminate our a and what? B. Now I would have said let me use simultaneous equation to solve this, but I am going to embark on a what? A determinant of what? A matrix to eliminate this what? Arbitrary constants. So I hope this gets you interested as I continue. Now what do you do? Using determinants of a matrix, to eliminate the arbitrary constants. Arbitrary constants, we are going to be having something like this. Understand this step that I'm about to embark on now. Your a is going to be on your first line. What is the word? What is the coefficient of your a? The coefficient of your a is exponential x. So you have your exponential x. What is the coefficient of your b? The coefficient of your b is what? Is x. And lastly, that function is what? Y. You write your y. I hope you understand what I have done here. Now come to the second one. What is the coefficient of your A? The coefficient of your A is exponential x. The coefficient of your B here is what? 1. Don't write B, it is what? 1. And then what is that function? The function is y prime, y what? Prime. Now come to this one. What is the coefficient of A? We still have it as what? Exponential x. What is on this other part? We have it to be what? To be 0. And then what is that function that we are into? We are into what? Y prime prime. Now you equate this to be what? 0. You equate it to be what? 0. Now what do we do next? We now start applying our steps in determinant of a matrix. Now don't forget that at this point you'll be having here to be your plus, here will be your minus, and here will be your what? Plus. And for us to embark on this journey, we have exponential x. Exponential x, it is carrying plus, so no need of adding plus exponential x because it is still the same thing. You open a bracket. When you have exponential x, any other thing that we have from down here that is not under exponential x, we'll write it out, which is 1, y prime, 0, and y prime prime. So you now have y prime, 0, and y prime prime. You close that bracket. Now you have it with minus x. Minus x. Now anything that is beneath minus 1, minus x, don't write it. Write other things. We have it to be exponential x, y prime, exponential x, y prime prime. So you have it here to be what? Exponential x, y prime, exponential x, y prime prime. You are done with that part. Now you now have plus y. Plus y. You open another what? Bracket. Now anything that is beneath plus y, don't write it out. You only write these things out, which is exponential x, 1, exponential x, and what? 0. You have it to be exponential x, 1, exponential x, and what? 0. All this is equal to 0 as I've said here. Now we now start doing our process. We now enter into the process. Now you have it to be exponential x, and then don't forget that in determinant of a matrix, the major diagonal subtracts from the what? Minor diagonal, which is 1 times y prime prime will give us y prime prime minus 0 times y prime will give us what? 0. Now minus x. The major diagonal will subtract the what? Minor what? Diagonal. So exponential x times y prime prime. We are going to be having exponential x y prime prime minus exponential x multiplied by y prime. You have exponential x y what? Prime. You are done with that one. Now you now come to plus y. You have something like exponential x times 0 will give us what? 0 minus exponential x times 1 we have what? Exponential x, still equal to 0. I'm sure you are getting interested in this class. Now what else are we going to do? You have here to what? You have to multiply everything that you have here by what? Exponential x, which is what you have here outside. So you now have exponential x multiplied by y prime prime. You have exponential x y prime prime minus this times 0 will give us what? 0. Now you have it to be minus x exponential x y prime prime. You'll be having minus x exponential x y prime prime. Minus times minus will give us a plus. X times exponential x y prime. You have x exponential x y prime plus y times 0 will give us what? 0. And plus y times minus exponential x. Plus times minus will give us what? Minus. You now have exponential x y. Sorry, it's not a prime. Equal to 0. Now permit me to clean this other part to continue our problem. Now, what do you have? You have here to be exponential x y prime prime minus x exponential x y prime prime plus x exponential x y prime and minus exponential x y equal to 0. Now let us look at this. We have exponential x here, we have exponential x, we have exponential x, we have exponential x. We are going to factor out exponential x. So when you factor out exponential x, you are going to be left here with what? Y prime prime minus here you will be left with x y prime prime plus here we left with x y prime minus y equal to 0. And then when you divide both sides by exponential x and divide this side by exponential x will cancel exponential x, and 0 divided by any number will still give us a 0. Therefore we will have that y prime prime minus x y prime prime plus x y prime minus y will give us what? 0. So this is the solution of our differential equation. But for us to group it together, we have it to be x y prime prime and y prime prime. You can factor it out and you have it that y prime prime is into 1 minus x, because what you have here, what remains here is where 1, and here we have to minus what? X plus x y prime minus y equal to 0. You may choose to represent it in this standard form, which is the square y all over the x square of 1 minus x plus x dy dx minus y equal to 0. So this is the formation of the differential equation. Now remember that I told you that the number of arbitrary constants determines the order of that differential equation. Now we have 2 arbitrary constants. Now let us look at the order. We have it as what? Second order differential equation. Thank you for watching this video. I hope you got this video interested and very, very understanding. Please like, comment, share this video to your other friends and subscribe. Thank you for watching.